Assalamualaikum and greetings everyone. Today's topic is on double integrals. There are 4 sections in double integrals. The first is on definitions and iterated integrals. The second section is on Cartesian coordinates and Fubini's theorems. The third is on polar coordinates, and the last section is on applications of double integrals. Now let's look at the first section, which is definitions and iterated integrals. Let's look at the first definition. The first definition that you need to know is about partial integration. Well, partial integration is really the reverse process of partial derivative, where we integrate with respect to one variable by regarding the other variable as constant. Okay, so let's look at an example. So here we have an integrand. The integrand is x plus 3y plus 7. And here we need to integrate with respect to y. So you can see that in the integrand we have x and also y term. But here we integrate with respect to y, meaning that we hold x as a constant. So it's the reverse process of partial derivatives. Right, see here we, okay, let's, oops. Alright, I need more room. Sorry about that. Okay, the first example is where we have x plus 3y plus 7, and we want to integrate this with respect to y from 0 to 3. So what we do is we integrate a term at a time, but remember we're integrating with respect to y, so we hold x as a constant. So the first term is x, so consider that as a constant. Integrate with respect to y, we get xy. The second term we have 3y, integrate that with respect to y, we get 3y squared over 2. And here we have a constant 7, integrate with respect to y, we get 7y. The next step is to replace y with upper and lower limits. Remember, upper limit minus the lower limit. So remember here 0 and 2, sorry, this is a 2. 0 and 2 are the limits for y. Okay, so now we replace y with 2. So we have x, we have 2 plus 3, 2 squared over 2 plus 7 times 2. That's upper limit. Minus the lower limit, replacing y with 0, get 0, 0, 0. So simplify this, we get 2x plus 6 plus 14, which is 2x plus 20. Okay, so that is partial integration, where we hold the other variable as constant. Okay, the second example, we still have the same integrand, which is x plus 3y plus 7, but now the integration is with respect to x. Okay, so it's with respect to x from 0 to 1. So now again, this is partial integration. We integrate with respect to x by holding y as a constant. So the other variable is y, so we hold that as a constant. So integrate a term at a time. The first term is x. Integrate with respect to x, we get x squared over 2. And here 3y is considered as constant. So integrate with respect to x, we get 3yx. 7 is a constant. Integrate with respect to x, we get 7x. And then replace x with upper and lower limits, which are 0 and 1. So remember, upper limit minus the lower limit. So replacing x with 1, we get a half plus 3y times 1. 7 times 1, that is upper limit. Minus the lower limit, replacing x with lower limit, which is 0, we get 0. Plus 3y times 0, which is 0. 7 times 0 is 0. And simplify this, we get 3y plus a half plus 7, which is 3y plus 15 over, oops, that's an ugly 50, okay, never mind, 15 over 2. Okay, so you can see here in the answer we still have y in it. That's ugly. Hang on, let me change that. That should be a 5. Alright, so that is partial integration. Okay, that is partial integration. Okay, the next term that you need to know is iterated integrals. Iterated integrals meaning that we integrate repeatedly. Okay, all right, so this is about iterated integrals. Right, let's say here we have a function fxy, And here you can see where we have double integral. We have the inner integral is where integration with respect to y, the outer integral is with respect to x. So the process of iterated integral is to evaluate the inner integral first. So here, if it's dy dx, meaning you integrate the function f(xy) with respect to y first, and then replace y with upper and lower limits, and then the next step is to integrate with respect to x. Okay, so here, if the order of integration is dx dy, then you do need to integrate your function with respect to x first. Okay, so integrate the inner integral first, and then replace x with upper and lower limits. Next is you integrate with respect to y. So remember, for iterated integrals, you start from the inside out. So in this case, integrate with respect to y first and then x. The second one, integrate with respect to x and then y. Okay, so here, note, we also deal with inner integration with variable limits. So sometimes you also have variable in your limits. We'll talk about that in much more detail, but here I'm just going to show you how to evaluate iterated integrals when all the limits are given. Okay, the next example is excuse me, example, I guess this one is example 3. We have 0 to pi over 6, 0 to pi over 2, and the integrand is y cos x. The order is dx and then dy. Okay, so here we have iterated integrals. So remember, you have to integrate the inner integral first. So in this case, we have to integrate with respect to x first. So if it's integration with respect to x, you hold y as a constant. Okay, let's do that. So the outer integral is still the same. Okay, we integrate y cos x with respect to x. So here, y is considered as constant. You only integrate cos x with respect to x, we get sine x. And then replace x with upper and lower limits, which are 0, pi over 2, and we still have dy here, the outer integral. Excuse me. So here, next step is to replace the upper and lower limits of x in our solution, the semi-solution. So here we have y. Okay, remember, upper limit minus the lower limit. Replacing x with upper limit, we have sine pi over 2 minus the lower limit, which is sine 0. We still have dy there. Okay, but we know sine pi over 2 is 1. So this is 1. And we know sine 0 is 0. So simplify that. We get 0 pi over 6. We have y times 1 minus 0. So that we have y. Okay, now we evaluate the outer integral, which is integration with respect to y. So we get y squared over 2. And then replace y with upper and lower limits. So we have pi over 6 squared over 2 minus 0. So simplify that. We get pi squared over 6 squared is 36 times 2. That would be 72 minus 0. We get this. Right, so that is the answer for item 1 here. Right, for item 2, I'm going to leave that to you for your exercise. That's all for this video. We'll continue in the next one. Thank you.